This is the answer key for the Unit 1 test for grade 12, and it's a good practice for nomenclature. So we'll go through it and we'll see how the systematic nomenclature works. Here we have a molecule with a 5-carbon ring in it and 3 substituents. And the highest priority substituent in this molecule is the ketone, which is here, then followed by the bromine and then the ethyl group. And of course it's done in bond line notation, where each elbow and each terminus represents a carbon atom, and the hydrogen atoms are assumed to be there, but they're not drawn. So we numbered the molecule clockwise, starting from the ketone group, and then we see that we get 3 bromo, 5 ethyl, this is the ethyl group right here, cyclo, because of 5 carbons in a ring, pentan, symbolizing 5, and one, so 3 bromo, 5 ethyl, cyclopentanone. Notice how there's 1 mark for each piece of information in the molecule. In the second molecule, we have an alkyne because of the triple bond. A frequent mistake is that students start counting from this position, but really you have to count the first carbon over here. So the first position is here, and you count through the molecule. There are chlorines at the 4th, the 6th, and the 8th position. So we call this 4,6,8 trichloro-nonine. The nonine because it's got 9 carbons. The third molecule is another cyclopentane with a carboxylic acid on it. So normally when you have a carboxylic acid, you add oic acid on the end of the molecule name. But because this carboxylic acid is on a ring, we call it cyclopentane carboxylic acid. The carboxylic acid is the first group, and then there are 2 substituents, iodine atoms. So 2,3-diiodo cyclopentane carboxylic acid. The iodo symbolizes the iodine atoms. The fourth of the molecules is a benzene that's substituted with an ethenyl group. There's a trivial name for ethenyl, and that is vinyl. So we can call it para-divinyl benzene because the groups are on opposite sides of the benzene ring. Had they been adjacent, they would be ortho-divinyl benzene. You could also call it 1,4-divinyl benzene, para-diethenyl benzene, or 1,4-diethenyl benzene. And also, we don't want to forget that if the groups are 1,3, then it's called meta. The fifth molecule is a substituted cyclohexane. It's got an aldehyde group, a ketone group, and an amine group, a halide, and an ethyl group. Normally you alphabetize the substituents. When you have a substituted substituent, you count the alphabetic order from the prefixes. So I'm a little bit uncertain about that because I don't know if you would count the N or the di. If anybody knows better, let me know. But I named it 4-bromo, so I started counting at the aldehyde group, which has the highest priority. Everything else is a substituent. So normally when you have a ketone substituent, or a ketone as a substituent, you would use the oxo designation. So this is numbered clockwise, starting from the aldehyde position. So 4-bromo, 5-ethyl, 3 NN diisopropyl. Why do I say NN? Because both isopropyl groups are located on the amino, on the amine group. And when an amine is a substituent, it's called amino. So we say 3, open a bracket, NN diisopropylamino. That names this whole group. 2 oxo cyclohexane carb aldehyde. When you have an aldehyde on a ring, you use carb aldehyde to name it. There are 16 pieces of information in that name, so I gave it 16 marks. In this example, we have the name. So I gave the name of the molecule, and we have to draw the molecule. So I said tert-butyl cyclohexyl ketone. Here's a tert-butyl group. Here's a cyclohexyl group, and it's connected to a carbonyl, so it's a ketone. The second example is an amide with 4 carbons, so it's butanamide. At the third position, which we shall number, here's the first, second, third, and fourth carbon. At the third carbon, you have a phenyl group, so we call it 3-phenyl-butanamide. The next molecule is called 3-oxobutanoic acid. You can see the numbering. There's butanoic acid. If it didn't have this ketone group on it, it would be simply called butanoic acid, also known as butyric acid. But because there's a ketone at the third position, we add the oxo substituent, so 3-oxobutanoic acid. The next molecule is a hexene with an ether on it. When you have an ether as a lower level substituent in a molecule, meaning there's something else of higher priority, like a ketone, or in this case an alkene. Well, normally alkenes are lower priority, I think, than ethers. But in this case, I think it makes more sense to name it 4-methoxy. So at the fourth position, we count from the right, because that way the double bond gets the lowest possible number. So we call it 2-methyl. Here's the second position. 4-methoxy. There's a methyl group attached to an oxygen, so this is an ether. And then 2-hexene. The second position is where the double bond starts, so that's where you call it. You say 2. Even though it ends at 3, you call it 2-hexene. Lastly, we have a fun molecule called 1,3,4-tricyclopropyl 2,5-diisobutyl cyclopentane. So it looks a little bit like a man running. Here are the cyclopropyl groups, and they're at the first, third, and fourth position. And there are 2 isobutyl groups as well, at the second and fifth position. So 1,3,4-tricyclopropyl 2,5-diisobutyl cyclopentane. Here's the cyclopentane. Here are the 3 cyclopropanes, and here are the 2 isobutyls. It's called isobutyl because there are 1, 2, 3, 4 carbons on it. It looks like an isopropyl with an extra elbow.